This is warm up, and it's going to lead into notes today. So if you do like notes in a separate section, and you got like 5 sections of your spiral, and one is for warm ups, and you do notes separate, like don't do that today, because warm ups is going to lead into notes. So call it warm ups, call it notes, whatever. And I almost never take up warm ups, so it's not like you need to keep them separate so that you can hand them in. This is going to lead into what we'll do today. So copy that first quadrant down. And Connor called it earlier. The cosine is the first coordinate, it's the x coordinate. Sine is the y coordinate. Okay. And remember, there's not a whole lot of values, so if you can just remember one of them, you can probably like kind of piece in the rest. So see how far you can get in just a minute or so, and then we'll come back and see where we're at. So it's a circle of radius 1. That's why it's called the unit circle, 1 unit circle. Cosine's the first coordinate, sine's the second coordinate, and keeping these two things in mind sort of at the same time is what allows us to figure out what's what here. So regardless of unit circle stuff, the coordinates of this point would be 1, 0, right? Over 1, up 0. That means that the cosine of 0 is 1, and the sine of 0 is 0. So that those two things you got to keep in mind for the unit circle. All right, how about at pi over 6? What's the cosine of pi over 6? Do you remember? Good, root 3 over 2. And the sine is 1/2. And then I'm going to skip to pi over 3 because the pi over 3 and pi over 6 kind of go together. They are switched. So the cosine is 1/2 and the sine is root 3 over 2. Remember, there's not a whole lot of values, and if you can just remember who the long side and the short side are. Right? Long sides are always root 3 over 2. Short sides are always 1/2. And what about if the sides are equal, like at pi over 4? How long are those sides? Root 2 over 2. And that's kind of all you need to remember. After that, you can work your way around the unit circle and quadrants and who's positive and who's negative. But that's the key values. After that, we're good. So with that in mind, try those 6 problems. And then we'll see where we stand after that. So cosecant is the flip of sine. Sine is negative 1/2. But we need to flip it. So negative 2. Yep. So I know it's been a while, but hopefully it felt like it was coming back for you.
On number 5, do you want us to multiply by like the square root of 3 to get it?
Great question. You don't have to. This is acceptable. Now, if you're in the habit and on a multiple choice, they might do it. So either one of those is correct. Don't box them both. I mean, it would be okay to box both, but if you box both and one of them's wrong, you're going to get counted wrong. So pick one. I'm boxing both to indicate that either answer is acceptable. All right, didn't show much work for the people at home. Hopefully you can think back, refer back, thinking about quadrants and links and all that stuff. You know what, I'm not going to make a separate video. Let's just cruise on into the notes because it's limits with trig, and so all that stuff we just talked about, we need to do limits with trig. And so it's a little bit like Friday in that some of them you just substitute and you're good, but then some of them there's a trick and we have to be careful. So let's do a couple of, I shouldn't call them easy, straightforward substitution ones. Limit as x approaches pi of tangent of x. So as always, we're going to try substitution first. Tangent of pi. Well, like we saw earlier, I don't have these memorized. I got to draw the picture every time and then think about it. Tangent is y over x. That coordinate would be -1, 0. So 0 over -1, which would be a safe stop. It's kind of as weird as that looks. But on a multiple choice test, the answer would be 0. The best answer that would be given is 0. Now, I have great news for you. It's a little bit disappointing for me as the pre-cal teacher for most of you guys, but the rule for safe stop is if the only stuff left is not calculus, you can leave it, or if it's calculator ready, you can leave it, which means tangent of pi is a safe stop. So if on a free response question you get down to cosecant of pi over 3, and you're thinking, oh man, which one's cosecant? Where's pi over 3? I got a cosecant pi over 3. You're done.
If you felt like you'd go out and just answer it either way, it's the same.
As long as you get it right. So if you stop here, you're definitely good. If you keep going and get to 0, you're good. The problem would be if you write tangent of pi and then mess up something after that and say, oh, maybe you get them backwards and say it's undefined. Well, then you're going to miss the problem. And I'm going to give you partial credit because I can see where the mistake was. But why risk the 2 points when you could have stopped there on a free response question? Example 2. Limit as x approaches 2, sine of pi x over 4. So that looks a little bit different, but why don't you try that one? It's a straightforward substitution one. So plug in 2 and see what happens. Plug in 2 for x, so sine of pi times 2 over 4. That reduces to sine of pi over 2. And the sine of pi over 2 would be 1. But again, on a free response question, you could back up all the way to there and be just fine because that's calculator ready. There's no more calculus involved in that one. Most of these, just a warning, most of these are going to be on the multiple choice part of the test because I want to continue to make sure that you know your unit circle. So I do want to test not just your calculus, but also your pre-cal. All right, so those are the ones that are straightforward. Like you plug it in, and as long as you know your unit circle or you're comfortable with the safe stop, then you're okay. All right, now there's a couple that there's no way to get other than one of those, my calculus teacher said so kind of situations. I mean, they both have proofs, but the proof is a lot longer than Mr. Wolf said so. So these fall into the category of I need to memorize these because I probably can't figure them out. Although I'll show you kind of how to figure them out if you get stuck between the two of them. Limit as x approaches 0 of sine of x over x. So, I mean, they're special trig limits. That's the category they're in. So substitution is probably not going to work. But we try that first. Sine of 0 is 0 over 0, 0 over 0. So that doesn't work. Well, here's the answer. It's equal to 1. And the second one, limit as x approaches 0 of 1 minus cosine x over x. Again, try substitution. Cosine of 0 is 1. 1 minus 1 is 0. You get 0 over 0 again. But this time, 0 over 0 doesn't go to 1. 0 over 0 goes to 0. kind of just have to memorize those. I'll give you the picture that helps me remember which one's which. Like I know they both start at 0 over 0, and then it's just like, well, how do I remember which one goes to 1 and which one goes to 0? And what helps me is the picture of the graph of this first one. So let's graph sine of x. I'm going to graph the sine of x and y equals x separately. What the graph of sine of x over x looks like, I don't know. But I do know what the separate graphs look like. Right, there's sine of x. And y equals x, that's just that line. And so my limit as x gets close to 0, so I'm looking right down here at the origin of the ratio of sine of x over x. Well, if I zoom in really far and just look really close into the origin right there, they look like they're the same thing. They're really close to each other. So it makes sense to me that that ratio is 1 because they're pretty much the same thing. Again, yeah, you don't have to memorize that. You can just memorize that it's equal to 1. But to me, the graph helps me remember if I can't figure out. I know one of them's 1 and one of them's 0. And you can do the same thing with cosine. The ratio of the 1 minus cosine. Actually, that's not 1 minus cosine, but the idea is kind of the same. Those don't look alike. If I graph cosine and I graph y equals x, that doesn't look right. So maybe the graphs help, maybe not. At the end of the day, you just have to know those two. Like, put that in the list of things you got to know. So some examples that use those. Right, we're not going to ask them straightforward. We're going to put some tricks in there. Limit as x approaches 0 of 3 sine x over x. Well, that 3 is kind of messing things up, but properties of limits, I could sort of just slide this 3 out front, and the limit of sine of x over x we just said was 1, so the answer is 3. So we use a combination of limit properties, slide the 3 out, and this new property that we just learned, put them together and we get 3. Right, the 3 can slide out front of the limit. 3 times the limit of some function is equal to the limit of 3 times the function. Again, limit properties are pretty forgiving. You can, if it looks like it makes sense, it probably works for limits. Limit as x approaches 0 of 1 minus cosine x squared over x. Minus cosine x cosine squared. Wait a minute, so that's not the property that we learned a minute ago. The property we had was 1 minus cosine, not 1 minus cosine squared. So we're going to have to do some work with this one. I guess substitute first, but we would get 0 over 0 if we plugged in, so that's not really helpful if we use substitution. Do you remember a property with sine squared and cosine squared?
Isn't it like sine squared plus cosine squared equals 1?
It is. Sine squared plus cosine squared equals 1. You don't need there's a ton of those type properties in pre-cal, if you remember that last year. Double angle formulas, addition formulas. You don't need most of those for calculus. You do need this one. This one shows up once in a while. So 1 minus cosine squared, if I move things around, would equal sine squared. Well, that's still not what we want, right? That's still not sine x over x. So I can't pull a sine out in front of the limit because there's an x in there, but you're on the right track. Instead of pulling out a sine, I'm just going to kind of rewrite it as sine of x times sine of x. And I only have one x in the bottom, so I'll put it under one of them. I can't put an x under both of them because that'd be x squared. This is good because now this we have a rule for. Sine of x over x, that equals 1. We can do substitution on the other piece. Sine of 0 is 0. And so 1 times 0 is 0. So that was kind of a sneaky one. It used algebra. It used a trig property. It used this new special trig limit, and it used some substitution limit. So like that short little problem used like 4 different things in it. By the way, there's other ways to work this. Like if you see 1 minus cosine squared and you'd rather factor it as 1 plus cosine and 1 minus cosine, you eventually get to the same answer. Different way, but you get there. Speaking of trig properties and trig algebra, limit as x approaches 0 of cosine x tangent x all over x. Well, that's not any of our special properties, so we need to do something with that. Any thoughts on what we could substitute, replace? Trig identities? The glimmer of an idea was there, Natalie?
Kind of.
What was it?
Would you do it's like tangent and then is it cosine and sine? I don't remember.
Okay, you're on the right track. What is tangent equal to? Sine over cosine.
Okay.
So you were thinking right. I'm going to replace tangent with sine over cosine, which is a great substitution for this particular problem, because what happens? The cosines will cancel. And now I've got sine of x over x. And that's the rule that I got lazy and dropped right in my limits here, but that's one of the rules that we just learned. The limit as x approaches 0 of sine of x over x is 1. So again, a little bit of trig, a little bit of algebra to figure that one out. Let's do 2 more. Limit as x approaches 0, tangent squared x over x. There's probably several ways to go with this one, because tangent squared was equal to secant squared plus 1, I think. I don't want to do that though. I'd rather think tangent is sine squared over, or tangent is sine over cosine. So I'm going to rewrite this as sine squared over cosine squared. Oh, sorry, yeah. And that doesn't really help a whole lot, except that I've got sine of x over x in there, kind of, and I at least know what that limit is. I don't like this fractions and fractions stuff, so I'm going to just kind of rewrite it like this. We did this earlier. There's kind of a sine x over x hidden in there, and I'd like to make that work.
Why can't you just put the cosine on the bottom?
So the long way around from here would be like keep it, change it, flip it. Keep it, change it, flip it. And so the cosine ends up in the bottom. So back to here, I know that sine x over x would help. So I'm going to rewrite the top as sine of x times sine of x. And the x down there, cosine squared x. Because now I can group that. That gives me 1. And then let's try substitution on the rest and see what happens. So sine of 0 over cosine of 0 squared. The sine of 0 is 0. The cosine of 0 is 1. So a whole bunch of 1s and 0s. And it ends up being 0. 1 times 0 over 1. Remember, it's okay to have 0 in the top. If you have 0 in the bottom, something's wrong. So we're okay with this answer. All right, last one. Limit as x approaches 0, sine of 5x over x. Well, you can plug in 0 and you get 0 over 0, so that doesn't really work. It's not exactly what we had hoped for in terms of the rule, because for the rule to work, this and this need to be the same, right? Sine of x over x. They're not the same. Well, I'm going to do an algebra trick here. If I put a 5 down there, now they're the same. But that's kind of illegal. I can't just throw a 5 in the bottom. If I want to put a 5 in the bottom, where else could I put a 5 that would keep things, kind of balanced or the same? I could put one in up top here. And now, that part's equal to 1. And that 5 that we added on is still out front. So 5 times 1 is 5. So another kind of algebra trick to make things work. All right, the assignment is from section 1.3. Again, Calc Chat for answers with work shown. 27 to 35 odd. 63 to 71 odd. The first set is just straight substitution, so that's more like unit circle practice. The second set requires some tricks, plus the 2 rules that we learned. All right, so try those. We'll go over them again, or we'll go over them tomorrow. And again, quiz on Wednesday, and homework due Wednesday as well.